This lesson is about the forms of quadratics, simplifying them, and also looking at the standard form and how we can use that in the future to help us with our graphs. So first of all, our objective is to simplify quadratics in this first part, and later our objective is to use the standard form. So let's go back to a review of Algebra 1, where we would want to multiply these two binomials together. So you probably used the double distributive rule, where you took your two binomials and you would distribute through the 2x to both of them and the 7 to both of them. Now how you usually did it is you wrote it like this: 2x times x is 2x squared, and then 2x times negative 3 is negative 6x, and then 7 times x is 7x, and then 7 times negative 3 is negative 21. We'd simplify that by going 2x squared. These two are like terms, so we can combine them. Negative 6x plus 7x is a positive 1x minus 21. Okay, so that's the double distributive. In essence, you're doing 2x times the x minus 3, and then you're doing the 7 times the x minus 3. Both of those are represented by that, so you're distributing twice. So now there's another method that you might learn that might help you. It's an option to use. It's called the box method. And if you take each of these binomials and list them like 2x and then plus 7, and then the x and the minus 3 here, you can use this box to organize your work for getting these different terms. So if I multiply these two like I would do the area of a rectangle, I take this times this and I get 2x squared. And then I take this one times that one because that would be the sides of this rectangle. So x times 7 is 7x. And then 2x times the negative 3 would be negative 6x. That's the sides of this rectangle. And then the sides of this rectangle are negative 3 and 7. Negative 3 times 7 is negative 21. Notice that gives me the same terms as I use here in order to simplify it and just organize that problem. So I know that these two are the similar terms. There's the ones that I can combine together. So this would give me the same thing, 2x squared, and then combine these two and you get plus 1x minus 21. Now let's do this example. Let's go ahead and use the double distributive property for doing this, or method. And so I'm going to take x times each of these, 5x squared, x times 6 is 6x, and then I'm going to do the negative 4 times each of these, so negative 20x, and then negative 4 times 6 gives me negative 24. Combine the like terms in the middle, so I've got 5x squared, and then plus 6, negative 20 is negative 14x, and then minus 24. So that would be my simplified version of that. Let's do this one. Now I'm going to do this one using the box method. This one, if you expand it out, it's x minus 8 times x minus 8. So that's what x minus 8 squared means. So I'm going to go ahead and list it as the sides of my box. So x and minus 8, and x and minus 8. So x times x gives me x squared. X times negative 8 is negative 8x. X times negative 8 is negative 8x again. And then negative 8 times negative 8 organized in this would give me a positive 64. So combining those, the middle box is I get x squared minus 8x minus 8x, and then plus 64. I can combine these middle terms, and that's going to give me x squared minus 16x plus 64 for my final answer for the simplifying that. All right, now let's take a look at the different forms we have for our quadratics. We did vertex form in a previous lesson, and the vertex form basically looks like this. We had y equals a times the quantity x minus h, the quantity squared plus k, and we said that our vertex is at h comma k. The opposite of what's inside and the same as the number outside. Now we're going to use what's called standard form next. Standard form is where you have y equals ax squared plus bx plus c. This is a more standard form of looking at a quadratic. That's what we'll use most of the time. It doesn't have the vertex pop out at you just like the vertex form, but we can calculate it. So looking at an example like this one here, this would be the standard form of a quadratic. Looking at this one, we'd have our a value is the coefficient in front of the x squared. Well, a here would be equal to 1 because there's not a number, it's implied to be a 1. B would be the negative 16. And then C would equal the 67. So we'll use those now in these examples to do different information. Well, for standard form, to find the vertex HK, we're going to use these values A, B, and C. So to find the vertex, you get the vertex is the x value. We'll call it, it's the x value of the of our vertex. We'll call it h here. So h is going to equal the opposite of b over 2a. This is a critical thing to know. We'll refer back to it many times. We'll connect it to other things in the future. Now to find the y value, or the k, notice that's k there. To find k, substitute h into the quadratic. Let's see what that means. Let's look at this example here. So to find the vertex, we're going to have h equal to the opposite of b. So we're going to have opposite of negative 16 over 2 times 1. That's going to be positive 16 over 2, which is equal to 8. So the x value at your vertex is going to be 8. Now to find the y value, the k value here for the vertex, you go ahead and put it into the equation. So we'll put 8 in for x, so we'll have 8 squared minus 16 times 8, and then plus 67. And when I calculate that out, I get a vertex value of 3. So my vertex here will be 8, 3 for my x and y at the vertex. Remember that vertex is critical because on a parabola, this one's opening up because the a value is positive. For a parabola, it's the middle value that the axis of symmetry goes over, and you've got symmetry on both sides. It's the value that if you're setting up a table, you put the vertex right in the middle of the table in order to find your other values. Now the axis of symmetry is just the x value at the vertex. So we'll just say it's x equals the h value there. So for this example, my axis of symmetry, make that look more like an A here. So axis of symmetry would just be x equals 8. So that's the x value. Now min or max, this thing opens up because it's a positive. So just a reminder, when a is positive, so we have a is positive in this equation, it opens up. So when it opens up, that means we're going to have a minimum value. And so there will be a min at y equals the y value at the vertex. So h comma k, it's going to be a min at y equals k. So this one, since it's a positive, it opens up. A is 1. I'm going to have a minimum at y equals the 3, which is my y value at the vertex. If a is negative, remember that means it's going to open down if it it opens down, there's a maximum point. It's up at the top. So we'd have a max at y equals k for that. All right, and then the last thing we want to do is be able to find the y-intercept to describe this. So when we look at this, the y-intercept would be when we substitute x equals 0. Well, what happens when you put in x equals 0 into our standard form, you get 0 for this term, 0 for this term, so it ends up being just c. So when that happens for the y-intercept, the y is always the c value in that original. So over here, notice if you put in 0 for x, you get 0 there, 0 for x there, you get 0 there. My y-intercept will just be y equals 67 for my y-intercept. All right, let's do some examples. Let's do 2 down here using the information we just did. So my a here is 2, my b is -12, and my c is 1. Those are the coefficients in front of the x squared, the x, and the constant out there. So for the vertex, you're going to just go h equals the opposite of b, which would be -12, all over 2 times 2, 2 times the a. So that's going to be equal to +12 over 4, which is a 3. Okay, now we find the y value by putting it in. So you can go y equals 2 times 2, or 3 squared, 2 times 3 squared, minus 12 times 3, plus 1, and that's going to give me, when I calculate that, I can just do that on my calculator. When I get that, I get a y value of -17. So my vertex is going to be 3, -17. My axis of symmetry is always the x value at the vertex. So axis of symmetry will just be x equals 3. And then min or max, this opens up because it's a +2 in front. So that means it's going to be a min. And when we do that, it's going to be the y value, y equals -17. That's what the vertex does. It gives me the axis of symmetry, gives me the min or max. And then lastly, the y-intercept. Remember, the y-intercept is when you put in 0 for x, these two will turn into 0, so you just get y equal to 1. Let's do this example. Notice that the a is the number in front of the x squared, that's -5. The b is the number in front of the x, that's -30. And there's no number listed out here, so we're going to say that c is equal to 0, because it's like having a +0 out here. So my vertex is just going to be h equals the opposite of b, -30, over 2 times a, which is -5. So remember vertex, I'll just put it here so you remember it. Opposite of b over 2a for the vertex, that x value, okay? Now when we calculate that, we get +30 over -10, and you get -3 for that, for my x value at the vertex. Now we're going to put in -3 in to get the y value at the vertex. So y equals -5 times -3 squared, put it in parentheses, minus 30, put in parentheses -3 because we're going to multiply it. When we calculate that, put it in our calculator and get the value, that's going to be a y value of 45. So my vertex is going to be -3, 45. Now right away, that gives us information for the other things. Axis of symmetry is just x equals the x value at the vertex. X equals -3, that's that vertical line that goes right through the vertex. Min or max, this has a negative in front, so it's going to open down. We're going to have a maximum point up at the top. So this max, where we find the y value for that, comes straight from the vertex. It's that 45. And then lastly, the y-intercept is where you put in 0 for x. You get 0 minus 0 plus 0, that's c value, so the y-intercept will be 0. So what we've discovered is we were able to simplify quadratics by using either the double distributive method or the box method. And then we were able to find information from the standard form. We're going to use this information from the a, b, and c in ax squared plus bx plus c to find the vertex and other information, mins and maxes, the y-intercept in order to graph them, and also be able to answer questions about quadratics.